Hey guys, welcome back. So this is not the lathe video. The lathe video will come at some points. This is, however, a part of the lathe video. This thing here is the coolant pump of the lathe. So this attaches to the leg over there, and this pump pumps the coolants. Problem with it is at some point, I think it's been, I don't know, sat on, dropped, something. So this top casting is completely deformed and broken. And so what we're going to do today is create a new top cap for our little motor. Actually, that was the rotor. The stator is here. I measured everything, so the motor is still good. It's a 3-phase motor. And the impeller and the pump, everything is still good. So what we need is this little cap. I've gone ahead already and started working on it. So this thing here started its life as a 120 millimeter, I think it's 6061 aluminum round bar, and it was too big for this chuck. So I've turned down a piece here. You probably don't want to know how I did that. That's why I skipped all of those steps, because I'm not sure it's the most OSHA approved method that I used. However, it worked. I still have all my fingers, everything's fine. This thing is all nice and trued up in here, and we've got it turned down to the final diameter. And so the next step is to make this little lip in here that indexes it on the case of the motor. And after that, we're going to drill a hole in the middle and then start boring out the inside of this. After it's all bored out and the bearing and everything is, or the bearing race and everything is in the correct position, we're going to flip this whole deal, grab it by the outsides of the jaws here, and work on the other side. Let's go. All right, so here's what we got. We're going to touch off on this face here so that we have the 0 of the carriage. We'll set the dial indicator right here into the carriage, 0 it as well, and then we'll be able to measure 2 millimeters deep, and we'll just take passes. And everything good. Let's go. So there's our 0. Now we'll set this thing somewhere in here, and we can 0 it out there. So if you see that, that's now on 10 mil. So if we move this way, we should get down to 8 mil when we're at our dimension right there. Okay, so the little lip is done. That indexes this on the motor. Next thing we need to do is drill this out with a drill and then bore it out to a dimension, so it doesn't have to be really precise, but basically we have to fit the coils up inside there. So I'm not going to copy the original cap exactly because it was cast and it's all bent at the moment, so I'm just going to make the bore big enough that it slips over the coils without touching anything, and that this wall thickness stays big enough that this whole thing is still strong. And we have only a couple critical dimensions on this, and that's going to be the inner bearing race here, so where it sits relative to this edge right here. So when we get this all bored out to this depth, I'm going to do it to this face right here first, then we'll measure exactly the bore of the diameter, the bore of the bearing race, or the bore that the bearing race needs to press in. We'll go ahead and hack this one up, get it out of there, and measure the depth as well. Probably not off this cap because it's all bent, but rather off the motor, off the rotor. And then we'll bore out the bearing race. Yeah, let's just try it. As you heard from that nice sound, it's a bit too fast. Okay, then what we need to do is quickly align the center line of the tool. And we'll do that with the live center, so excuse the moving around here. I'll just set you guys up right there. So what we do is pop the live center into the tailstock, bring it up here, scooch you over, and then we'll rotate around this tool until we can get it just close to the tailstock here, and then you can see how far below center that is. So we'll go a little bit above center so that the cutting force that's pushing down on the tool will rather put it to the center when the tool gets loaded. And make sure you do this when your tool is locked. Okay, there we go. All right, we've reached the climax of our story here. So I managed to hack out this kind of included cylinder on the inside bore here. Our one critical dimension on this part, and that's the inside bore here, which is going to have a friction interface to the bearing race here. If you would focus. You piece of shit. So I hacked this bearing race out of the would you fucking focus. There we go. So that's the bearing race that I got out of the top cap, the old top cap, which interestingly enough completely crumbled the pieces when I squeezed it in the vise. That was kind of interesting. There's the remains of it. So I got everything kind of measured up. We have a couple of things to take care for. Here's the motor. And so I measured from this surface right here to the top of the bearing, including this little washer that was behind it. And that's going to be my depth from there to there. God, this camera. And that's it. And the bore, we need to get it to this number right here. This 5 scares me a little bit. So the bearing is actually 24. So I'm going to do a 5/100th press. If I can get it that close, should be able to. Let's give it a shot. Okie dokie, I fitted on the motor. Everything fits real nice with those last couple of passes on the ID here. So the bearing also lines up in the right place, so that's all super. What we have left to do, I thought about it a little bit more. I think I'll take off this end here, so that'll be a lot of turning, a lot of facing, because I don't think my parting tool can do that, but maybe it can. I'll have a look. But here it'll get stuck. Nah, that probably won't work. So we'll probably face this off and then put a taper on here, clean all this up, make it all nice, and then it should be done. Then we need to drill the 4 holes to mount it to the motor, put it all together and see if it works. Okay, let me explain. Today is maybe 4 or 5 days after that last shot you saw, and the following things have transpired since then. See that? It's Let's remove this little guy right here. What ended up happening shortly after that last shot was that I broke off a drill bit inside this hole. And if that wasn't enough, I flipped it over and broke off a second drill bit on the other side. And that started a probably 2 or 3 hour long process to get the drill bits out and to get this thing drilled out. After that, I chucked it on the shelf for some time because, well, you can imagine, I was pretty frustrated at that point. So it sat on the shelf for a couple of days. And then I ended up coming back to it. I don't know if you remember at the very beginning of the clip here, there was the shot of the stator where it had just 6 wires coming out. So each coil of the 3-phase motor just had both sides coming out. There were no labels, it was all just cut off. So then I had to mess around a lot with getting the orientations of the coils and the direction and everything correct here. I got it all done. This is by no means the final wiring. This is just to get it running. Though it does look kind of nice with the electrical tape. Maybe I will leave it like that. Yeah, so this thing works now. I got the motor all working. I don't know if anybody's interested in how you can get a motor hooked up if you have no idea which phase is which and which coil is oriented in which direction. I can make a video about that. That's, however, a separate topic. It's kind of complicated and not really in the scope of this video. So if you want that, write a thing below. Here's a nice little shot of this thing running. It works. So the next step, which I'm not going to do in this video, I'll do that in the lathe video, is we're going to mount this on the lathe and plumb the little coolant pipe here in that I can have coolant. And that's kind of all what I got for you. See you in the next one. Ciao-y.